So we'll continue exercise 2b. The first problem in today's class is, if two circles x square plus y square plus 2gx plus 2fy is equal to 0 and x square plus y square plus 2g dash x plus 2f dash y is equal to 0 touch each other, then prove that f dash g is equal to g dash f. So here the condition is two circles touch each other. So already we have discussed in the circles, if two circles touch each other, the condition is d is equal to r1 plus r2 or d is equal to r1 minus r2. So here d is equal to r1 plus r2 if two circles touch each other externally, and d is equal to r1 minus r2 if two circles touch each other internally. So here in this problem he mentioned that two circles touch each other, but he did not mention whether the circles touch each other externally or internally. So in this case what we can do is, as he didn't mention about two circles touch each other internally or externally, we can use any one of the condition. That means you can use d is equal to r1 plus r2 or d is equal to r1 minus r2. Any condition you can use and we can prove this. F dash g is equal to g dash f. Okay, any one we can use, as he didn't mention about external or internal. Okay, so before using that d is equal to r1 plus r2 or r1 minus r2, first what we'll do is we'll find out the center and radius of the given circles. Okay, so so what is the center of the first circle? Center of the first circle is minus g comma minus f. So we'll write it minus g comma minus f. Then after that, the center of the second circle is minus g dash comma minus f dash. Okay, then after that we'll find out r1 of the first circle. So r1 is equal to under root of g square plus f square, g square plus f square minus c. So constant is not there, so it is 0. Then we'll find out r2. So what is r2? r2 is under root of g dash square plus f dash square. See, g dash square plus f dash square, and constant is not there, so we will not write. So now, given that two circles touch each other, that's all. Just write given two circles touch each other. As two circles touch each other, the condition is d is equal to r1 plus r2. Okay, so now what I'll do is, I'll see you can use d is equal to r1 minus r2, you'll get the same result, f dash g is equal to g dash f. I'm taking d is equal to r1 plus r2. So what is d? D is the distance between two centers. So I'll find out here. So first I'll find out d. D is nothing but the distance between two centers, that is under root of x2 minus x1 whole square. x2 minus x1 whole square plus y2, that is y2 minus y1 whole square. This is d is equal to r1 plus r2. Already we have those. r1 g square plus f square plus r2 under root of g dash square plus f dash square. So we substituted. Now after substituting, what we'll do is, to eliminate the roots, we'll square them on both sides. I'm squaring them on both sides. So now when we square them on both sides, minus g dash plus g square plus g whole square plus of minus f dash plus f whole square under root whole square is equal to under root of g square plus f square plus under root of g dash square plus f dash square whole square. So we are squaring them on both sides. Now here square and root get cancelled, so we get minus g dash plus g whole square plus of minus f dash plus f whole square is equal to, and this one we need to expand in the form of a plus b whole square. So when we expand, we get a square. When we write a square, square and root cancels, plus b square, it is g dash square plus f dash square. A square plus b square plus 2ab, that is under root of g square plus f square into, you can write in one root into, okay, we write one more root also, we write under root of g dash square plus f dash square. See, a square plus b square plus 2ab. Then after that, we just simplify this. So it means we have to expand this. So I am expanding. It is g dash square plus g square minus 2g dash into g plus f dash square minus 2f f dash plus f square is equal to g square plus f square plus g dash square plus f dash square plus 2 into, in one root we will write of this, g square plus f square into g dash square plus f dash square. Right, so now we wrote off this under root. Now here we have some cancellations, that is, see, g dash square cancels, then g square cancels, okay. Then after that we can also cancel this f dash square. Then after that we can also cancel f square. Now what do you, after cancellation we will write the remaining, after cancellation all these terms we will write the remaining terms. After cancellation we have 2g g dash minus 2f f dash is equal to 2 into under root of g square plus f square into g dash square plus f dash square. Right, so now I'll take minus 2 common, so we get g dash plus f dash is equal to 2 into under root of g square plus f square into g dash square plus f dash square. I took only 2 common. Okay, 2 common, then I wrote the remaining. So now we can eliminate 2 and 2. So cancel 2 and 2. So after cancellation, what we do is, to eliminate the square root, what we do is again we will square them on both sides. So again square them on both sides. So we get g dash plus f dash whole square is equal to g square plus f square into g dash square plus f dash square. Now we are squaring them on, when we do square them on both sides, the minus sign also cancels and we get this. Now I'll expand this. So when we expand, g square g dash square plus f square f dash square is plus 2g g dash f dash. Okay, we expanded this, is equal to, we'll multiply g square g dash square g dash square plus g square f dash square, then we'll multiply with f square plus f square and g dash square plus f square and f dash square. So we multiply. So after multiplying, just check any cancellations are there or not. So here we have some cancellations. G square g dash square cancels. Then after that, f square f dash square also cancels. After that, what we have, we write this is equal to, see, we have this g square f dash square. I'll write it as g f dash whole square. Then this term we have, what is this term, f square f dash square, that can be written as f g dash whole square, f g dash whole square, and 2g dash ff dash will transpose on the other side. This will become minus 2g dash ff dash is equal to 0, right? Now this is clearly a square plus b square minus 2ab. So a square plus b square minus 2ab is nothing but a minus b whole square is equal to 0. A is gf dash, b is f g dash whole square is equal to 0. Okay, so now after this what we do, I just continue here. After this see, gf dash minus f g dash is equal to 0. That means here gf dash minus f g dash whole square is equal to 0. When we send square on the other side, it will become root. Okay, when we send square on the other side, it will become square root. So square root of 0 is 0. So that's why I wrote gf dash minus fg dash is equal to 0. So now clearly gf dash is equal to fg dash. Okay, so this is completed. This is very important problem. Next problem. Find the radical center of the circles x square plus y square minus 4x minus 6y plus 5 is equal to 0. X square plus y square minus 2x minus 4y minus 1 is equal to 0, and x square plus y square minus 6x minus 2y is equal to 0. So you have to find out the radical center of the following circles. Now what is radical center? See, radical center means, so here we have 3 circles they have given. Okay, just draw the circles like this. 3 circles they have given. Now radical center is nothing but the point of intersection of radical axis of pair of circles. Okay, or simply we can say the point of intersection of radical axis is radical center. Now we have 3 equations. Say this is circle 1, this is circle 2, and this is circle 3. Now first what we have to do is we'll find out the radical axis of any 2 circles. We'll find out the radical axis of any 2. This is equation 1, equation 2, and this is equation 3. So just first, before solving the problem, I'll just tell what is radical center. Radical center is the point of intersection of radical axis. Now 3 circles are given to us. This line, the vertical line, represents the radical axis of the circles 1 and 2. Okay, now next one more line I'll draw. This is a radical axis of 1 and 3, right? And one more line also we can draw. This line represents a radical axis of 2 and 3. Now all these radical axes meet at one point. So this point is known as radical center. Okay, this point is known as radical center. Now how to find the radical axis of 2 circles? The radical axis of 2 circles, s is equal to 0 and s dash is equal to 0, is s minus s dash is equal to 0. That means simply we have to subtract the 2 circles. If you subtract 1 and 2, you will get a line. That line is nothing but a radical axis. So to solve this problem, to find the radical center, what I do is, first I will find out the radical axis of 1 and 2. The radical axis of 1 and 2. That means we need to subtract these 2. Radical axis of 2 circles is nothing but s minus s dash is equal to 0. Now we have to subtract the 2 circle equations, that is x square plus y square minus 4x minus 6y plus 5. Then again it is minus of x square plus y square minus 2x minus 4y minus 1 is equal to 0. Now when we subtract, what we get is minus 4x plus 2x minus 4x plus 2x minus 6y plus 4y plus 5 plus 1 is equal to 0. So x square y square terms gets eliminated. So we get minus 2x minus 2y plus 6 is equal to 0. So I'll take minus 2 common. So I'll get x plus y minus 3 is equal to 0. Put this as equation number 4. So we got radical acts of 1 and 2. After that, what I will do is, you can find out the radical acts of 1 and 3 or the radical axis of 2 and 3. Now you have to take any two. First we did for 1 and 2. Okay, now we can do it for 2 and 3, or you can do it for 1 and 3. So I will do it for 2 and 3. So next, the radical axis of 2 and 3. The radical axis of 2 and 3. So what is equation 2? It is x square plus y square minus 2x minus 4y minus 1, and minus of x square plus y square minus 6x minus 2y is equal to 0. So we just simplify this. So x square y square terms gets eliminated. So we get minus 2x plus 6x minus 4y plus 2y minus 1 is equal to 0. Minus 1, only one constant we have as it is. So minus 4y plus 2y. So we get 4x minus 2y minus 1 is equal to 0. Put it as equation number 5. Now we have the two radical axes. So if we solve equation 4 and equation 5, we will get a radical center. Okay. So first we did for radical axis of 1 and 2. Next we are doing radical axis of 2 and 3. And now solve this equation 4 and equation 5, we will get a radical center. So now we will solve. Solve equation number 4 and 5. Right. So when we are solving, what I do, either you have to eliminate x term or y term. Here I will eliminate y term. Here coefficient of y is minus 2. So I will multiply this equation with 2. So that I can eliminate y term. So now 2x plus 2y minus 6 is equal to 0. And the fifth equation is 4x minus 2y. 4x minus 2y minus 1 is equal to 0. Now plus 2y minus 2y directly cancels. So we get 6x minus 7 is equal to 0. So x is nothing but 7 by 6. Now after getting x value, we need to find out the y. So what we do is substitute x is equal to 7 by 6 in equation. You can use either 4 or 5. I am substituting in equation 4. So substitute in equation 4. So what is equation 4? It is x plus y is equal to 3. So it is 7 by 6 plus y is equal to 3. So what is the value of y? It is 3 minus 7 by 6. So y is equal to, we'll take LCM, we'll simplify this. It is 18 minus 7, 18 minus 7 by 6. So clearly y is equal to 11 by 6. So what is the radical center we got? The radical center x comma y is equal to, first you write the value of x. It is 7 by 6 comma 11 by 6. So it is 7 by 6 comma 11 by 6. Okay. So this radical center problem is completed. Similar to this problem, previous problem, find the radical center of the circles x square plus y square plus 4x minus 7 is equal to 0. And the second equation is 2x square plus 2y square plus 3x plus 5y minus 9 is equal to 0. The third equation is x square plus y square plus y is equal to 0. So here you have to find out the radical center of this given circles. So this is the equation 1, you can take directly, but divide this equation by 2 and put it as equation 2. Then this is equation 3. Okay. First find the radical axis of 1 and 2. First find the radical axis of 1 and 2. Next you find the radical axis of 1 and 3. Okay. See, find the radical axis of 1 and 2. Or that is compulsory. Find the radical axis of 1 and 2. Then you can find the radical axis of 2 and 3. Or you can find the radical axis of 1 and 3. Okay. So find out the radical axis, you will get two equations, solve them and find the radical center.